I know, it's not very obvious.
It's not. Yeah.
Yeah, I don't know. I mean, like, for me, it makes sense because, like, I saw it over for, like, a couple of years. But then, like, I'm starting out, like, so, like, yeah, this way is too bad.
The problem is
Because, like, when I say, like, I'm thinking about,
Hey,
We're good with Pandas and everything.
I'm using YouTube Live. What I'll do is it's recording right now.
Okay.
I'm gonna download the MP4 file,
Okay.
then upload that to Panopto.
Whatever. Thanks.
Yeah, it's a great
Did I
workaround.
send you? Did my Panopto login network?
So it works and everything. The thing is with Panopto is you have to download the software to record. That software only works for OS or Windows, the Linux distribution. Tom's case is a little bit different. Yeah. But yeah. So
Okay.
my workaround is typically like non-installation,
That's
like
fine.
that kind of stuff. Yeah.
Whatever works.
I know, right? Yeah.
I don't really care. So okay. Do you need anything?
Pretty solid. Yeah, I think. Yeah, I got my awesome TAs.
Okay.
Yeah.
All right. Yeah, there.
Yeah. They're helping out right now. And right now I'm sending a message to remote users that I will start soon. Yeah.
Okay.
Yeah. Are you still gonna be on campus?
I will be, but I'll be in another class today.
Nice. Did you bring snacks?
I didn't. Well, I did, but then I gave them all away. I'll try to bring you guys.
No, it's okay. I have sparkling water, so I'll try to fill myself up.
Oh my god, I got an apple. You want an apple? No, you do. You're hungry. You're clearly hungry.
Yeah.
I don't need it.
Okay, thanks. I'm like, I was like, I forgot to get something that's not on. Thanks. Ooh, it's a green one. It's awesome.
Okay.
Yeah, I assume it's Costco.
Huh?
Costco apple.
I don't know where my husband got it.
Never
Safeway, maybe. He does most of the shopping and cooking and
That's cool.
life.
Yeah, of course.
Life stuff.
Yeah. Cool. So yeah.
Thank you, Rob.
Alright, so while I'm meeting with my mouth full, I'm sending a remote link right now. If you, any chance, think the remote link is, the remote video stream is messed up, let me know. Second thing is, I won't have a lot of technical issues as I did in the last session. My files for this evening won't be corrupt. So that's pretty awesome. Interact with more commands and whatnot. And then pretty soon I'll start up. I'm going on one assignment from the last session and then just start today's material, like literally today, because the remainder of what was from the last session is just like small bits and pieces that of like learning some certain like functionality, which you'll revise in this session. Also, those solutions are up on GitLab for that. Can someone test that stream? See if that works. I posted it in the announcements channel. At the same time, while it's being tested, I'm gonna start up my Jupyter notebook. for those who, yeah, kind of forgot. All right, so I'm gonna go into the directory that I want to go into. You don't have to necessarily do this, but you can just type in Jupyter Notebook, start it up at your like wherever your terminal or command prompt open up. CD. I'm going into a certain file path. I forgot everything. And then now that I'm in my directory, just because of like preference of like how I want to navigate through a path, I'm gonna type in Jupyter Notebook. That's the Y, and then start the server up, and then the window should have popped up there, but the last window I interacted with is over here. So let me actually just put this guy away. Oh man, the terminal? Yeah. I don't know how. Does anyone know how to zoom in on the terminal? Yeah. What is it? Wait, can we zoom in? I don't know. Oh, yeah. I literally don't know. I did like Control Plus, which obviously doesn't.
I think you control and you roll the mouse.
Wait, where's your mouse?
Yeah. Oh, I don't have a mouse.
Where's your prompt?
Oh, it's right there. Yeah, right there. All right. So.
Wait. Oh my God. How am I supposed to?
Right.
Can't see from here.
I know. Yeah. Yeah, my Jupyter up.
You go to view.
Actually, you go to right there.
You zoom in.
Is there like a hotkey?
So Control plus. Oh wow.
Didn't work. No. Why you gotta zoom in? Zoom in. So that's a little bit better, right?
Yeah.
Cool. Oh, really? What's going on? So right now you should have a terminal up. I don't know what that is. Oh, okay. Like now I can't scroll through it. That's pretty weird. Whatever. So the server was up and running for PC users. By the way, Anaconda prompt is where you want to go to. Anaconda prompt is basically command prompt, but with like all the Anaconda related paths configured to like and etc. So it takes away for PC users like that the issue of like installation, like setting up your paths to certain libraries respective of that Anaconda installation, as a fun fact. So yeah. So today is day 2. Let me go here. Activities, and let's go towards the end right here in this instructor section. And then over here, I'm going to go through the student solutions so we can quickly get to base.
Could you go into the paths and then
Yeah, so it's kind of your, for me, it is week 4, Pandas, day 1, activities, and then exercise 14. And then this is like just touching on basis on one thing I didn't touch upon in the last session.
We don't have 14.
But you guys have 15?
No, we only have 11.
That'll come out later. Or if any TAs are available right now, just slack out. Day 1, 14. Okay. And then in the meantime, once that populates on the Slack channel, you can just go through with this with me. But right now, let me just start. So So here we, again, just as typically, we're going to install our dependencies. Libraries are typically Pandas and NumPy. NumPy is more of a scientific calculation-related library. And then Pandas is, of course, the one where the library we use for the data type object of data frame series and so forth, and making our working with data a lot easier. Okay, that's like a quick little rehash. And then say file path. And here we're going to read in our whatever file may be. And then also we're going to do an encoding with it, reading particularly our CSV. And for that is, with our alias for Pandas, we're going to use this read CSV to read the CSV with an encoding of some type of encoding. I don't know what that encoding actually is, but there are some cases where, say, if you're downloading a file from a different country and it may have a different like decoding or encoding with it. If you open it up without specifying that encoding, whatever you open up may be like kind of corrupt or come out in some like weird syntax or like kind of jargon. And again, don't know what this one really like translates to, but for excluding this, for most of our cases, when working with CSV files, we're using UTF-8 related like formats. So there's that, and that's always implicitly that's the implicit parameter whenever you're not specifying an encoding. And here we want to see the first top 5 rows of our data frame.
So the ISO number, how do I find that?
iOS number?
The ISO would be 5.
Yeah, so whoever constructed this probably like did some research into finding that out. For me, in one case, I downloaded a data set from like a German website. Like I didn't notice it was like a German website, and I was trying to figure out what in my error output, what was happening. I copied and pasted that error, put it on Stack Overflow, and then over like a few minutes, I found out like the specific encoding that I needed.
Just look for it somewhere.
Yeah, yeah. It runs. Huh? Oh, sweet. And here I have an error because of my file path is incorrect. So let me type in resources. Files found. And then here we're, like I said, going to have the top 5 rows. And then if you want the last 5 rows of your data set for the case of like, say if your data set's kind of like ordered by some time or something like that, you can just df.tail and you get the last 5 rows, and then there's the specified indexes to be left.
So is the data in the CSV file already formatted as a data frame? Is that what's happening?
Yeah, yeah.
Okay.
So it's like translated into a data frame, and how that's done is you don't have to specify the delimiters, but within that read CSV function right here, there's a default of like, okay, the delimiter is a comma, because typically for CSVs, they always have commas. I believe TSVs are tab separated. Yeah.
So it's by default, is any time you read from the CSV in Pandas, it's putting it in a data frame?
Yeah,
So
yeah.
the way it was row before.
Yeah.
Data frame. Okay.
Yeah. That's cool. And for any file, not any file format, for quite a few file formats, you can make it into a data frame. So here what I did is pd.read, and I hit a shift tab. I think that's also for Mac users. Or I can hit, yeah, shift tab, and then I can read from the CSV, Excel, Heather, I don't know what that is. Some of you guys know. HTML, JSON, and CSV and Excel will be popular coming up, or whenever you're working with data.
And it would put all of them into a data frame.
Yeah,
Okay.
yeah, and based on how like you configure your parameters and so forth, hopefully the indigestion of like the data into this function isn't too nasty. Everything should come out like fine. Or else you have to do like maybe some like data cleaning before like processing that stuff in the function. And then to check that out again, you just hit pd.read and then shift tab to like find out like what available functions there. Okay. And let's go down here. We're gonna delete some extraneous columns. Okay, cool. Didn't know that. So you can type del for delete, and then you can delete the field 8 that was above here, and then from there you can see that the column was deleted and it was permanent deleted from the column. So and the reason why I say that is because there's certain cases where when you're trying to like do an operation on your data frame, and you continue on in your like calculations, but the same original information was like preserved, and you're like, wait, what the heck? I just divided the whole column by 7. What happened? It's because you didn't like overwrite that information. So here, what I just saw, I was like, oh, okay, this command right here for this specific column of the data frame does permanently delete that specified column for the data frame.
But you're saying permanently delete, but this is all just loaded into memory, right? So.
Oh yeah. So permanent delete it like with respect to like what you're doing right now, but not the actual.
The source file.
Yeah. Okay.
Just read the source file again and get it back there.
Yeah. So let me go back. Actually, let me go here. So let's test that out. Okay.
Oh, it lied.
In this example, sorry, I didn't catch this because I was late.
Yeah.
This is not something that we have in our GitLab stuff. This is not.
No. Yeah. Yeah. They're.
just flag it out.
Yeah.
It's a swimming data.
Thank you.
USB.
That's day 2. Day 2 for. Here's 14 here.
Oh, it's day 1 though.
Day 2 for.
Yeah. This is day 2. I'm just So brief bit. I'm going over one section from last section, just like catch up on like, okay, what are the overall concepts that and together you're supposed to learn last session, and then kind of bring that back, that rehash and right now, and then continue on with the material we're working on today, which is going to be how can I traverse a data frame or index it. How can I do group by operations? In the last session, there was like some talks about SQL. And how can I even like sort a data frame? So we'll kind of go through all of that and just overall like, yeah, traversing the data frame or kind of like some manipulation, but not too heavy manipulation of the data frame. So continuing on. But yeah, this is weird here. That did not delete. So I think I was right. Anyways. Yeah. So this is probably an error. So deleting this temporarily did it, but when I rerun that same data frame, that column that we supposedly deleted is still there. So I don't know. But what typically you would have to do in this case is, I remember. Well, no. Honestly, you could just do. Probably how I just have like the whole entire array of columns. Nah. I'll do it later. If you guys are interested. Okay, continuing on. So now we want to do a count of everything in the data frame. The count of all rows in the data frame for every respective column. Running that, we have a lot of values coming up, right? And we should, with dot count, we should see like 1776 all across the board. Why isn't the case we're not seeing 1776 rows all across the board for this data frame? It's probably like mentioned. There's like a hint on the top.
Like the comma by comma next to each other, right? There's blank space.
Yeah. So there's like null values. Oh, yeah. Blank values I think might count. Yeah, if it's a string, I column, it should count. Yeah. But that's not there. So here we want to drop all of our missing information. So we would do a drop NA. So what that's saying is for the whole entire data frame, drop the rows that have at least one NA or like null value. And how? It's any. So let's check out that
What does
parameter.
that mean? How?
Girl. Let's go down. Any and all, default any. If any NA values are present, drop the whole entire row. That's the default. And then all is if all values are NA, okay, drop that row or column.
Wait, so you, if
Okay, that makes
the
sense.
entire column would get dropped if there's one empty value in one of the rows?
So if there's one empty value in one of the rows for the any parameter, that whole row gets dropped.
But not the column. The thing drop that row or column.
Yeah. Can you do it by an axis? No. Okay, by axis. You can.
So you
Yeah.
pick one or the other,
Yeah. Default, it's 0.
which is rows.
Yeah, and then ones typically are columns, and then that is inspired by like mathematics or like linear algebra and all that good stuff.
So you're not defining it here because it's a default, so it's only going to delete rows.
Yeah.
This-
Yeah, and rehashing that to the whole class. The reason why a column isn't getting dropped is because, like you said, the default for axis is 0, which that whole row is getting deleted. So let's run that. Everything's deleted. See the count of values. Everything's gone. There must have been a null value all across the way for that. Okay, it's interesting. I'm not surprised. Okay, we're running. What I did here is I just reran everything again, starting from the top. You see that by the row number of cell number. So 17, 18, 19, going down, and I re-instantiated everything with a fresh data frame. If you're ever trying to do just like a quick troubleshoot, you can do that, but just keep in mind, like whenever you do operations again or some misorder of operations, that like you may get the improper results or unexpected results that you'd expect. Yeah. So going down, let's go to df.DTypes or DTypes. Here, just print out this function. Just prints out the series data type for every column. So right, every column is, or column header is a series, and the collection of all these series is data frame. And this whole data frame is an object.
Search by topic for movies.
That's really creepy. I always wondered, like, how did that happen to people? And I just found out. That's weird. I don't know. Okay. Let's go down right here. So now we want to, for some column, we want to put it to numerical values. How do we do that? We say the pandas library dot to numeric data frame, specifically this this column. We're going to convert that to a numerical value. And since this is a reference, and this reference is like something's happening to it, we store it back into the original data frame amount, and that amount is overwritten as a numerical value. And yeah, so what's happening here is the data frame, excuse me, the column amount of the data frame is being converted to numeric for the whole column, assuming like it has numerical values and no strings, right? It's being converted to numerical values. And say if I didn't assign it back to itself, then that operation is just done, and then that's just it. It was never like what we'd expect that operation to be done and then preserved back or saved back into the data frame or that specific column. To actually do that, you have to like reassign that reference and then like overwrite that column.
Does numeric to numeric gives out integer values or float values?
Let's find out. Yeah. So here, and then running this, it's still a float, 64. So I think what it just does is say if it's like column strings, but you know it should be classified as like some numerical column, then you do that to change it to some numerical value. Say if even say if that column had no decimals or no like decimal point in it for all those numbers in the column, I can assume that Pandas would turn that into int64, like integers. Yeah, and so since there must be a decimal, like some decimal places in the column, it automatically, the function automatically converts that column into float 64 decimals.
So Pandas tries to guess based on what, like if you have a whole column, it'll look and see. Okay, so you have like one or two rows that have like a really huge, like something that's like not an integer and like everything else is integers. Is it going to have to change though? Like will it predict based on the outlier?
Well, so for that, say if you had decimals, then that whole column would turn, float. If it's like strings, errors, for sure, right? Because
you have one string by mistake, you'll set the whole thing to string.
Yeah. And that would just require some like data cleaning. And later on, or you'll learn how to do data cleaning with using Panda functions. You'll see how light it is to clean a data set using Pandas as well, which also is like a great not benefit or great addition to working with a data frame or a series and so forth. And that's why it's also why it's like popular in the data sphere. Value counts, you're all familiar with that. Just a quick rehash. So for every column, for one column, we want to get all the unique values and count the occurrences of those unique values. And that we get those unique values and the counts of those for that column. Okay, and say if our output's way too long, as I mentioned before, coming down in the middle, rather than printing out the whole entire output and having a lot of white space and like scrolling down all that good stuff, within Jupyter Notebook, it just crunches that all down into like ... and just has the output is just like the remaining rows.
Is this federal election data that we're looking at?
Well, let's look. Donors.
So, like,
I would say yes.
I'm just curious.
Yeah, so the information's donor information.
So like itemized contribution.
For voter registration, so when you click,
Sorry.
Donation money.
So like FEC contributions.
Okay.
It's like FEC data.
okay. I don't know what that means, but
I
okay.
just don't see the CSV column. I'm curious.
Oh, okay, yeah, of course. So going down, we want to replace values with some certain values. So say going down and going down to one column, you're like, wait, there's too many spaces between something, or like something is just wrong for this one particular value, and it's just like reoccurring all in that one row. You can just replace that one value with the correction for quick cleaning. And specifically here we have self-employed, and like we want that to have like a hyphen in the middle, so we put have the replacement in there as the value for that key value inside the dictionary. And then there we go. And so that's one other alternative to doing some data cleaning on the spot. Okay, let me continue on. So the value counts.
So like none is not null. It's like somebody physically put none in the box because you already dropped the null.
Yeah. Yeah. So that would be a
So the words NONE are inside that field.
Yeah. Going down, you just see this output, and then here again for this replacement operation for the column. We will place not employed with unemployed, but we want to make sure we save that to the data frame, specifically that column. So how we're going to do that? We're going to reassign it to a variable, not a variable, but rather specifically employer column of that data frame, and it's like overwritten. Yeah.
So this is a single replace of non-employed to unemployed, whereas one up above was, can you scroll through?
Yeah.
Was a double replace. So you're replacing self-employed without a space to self-employed with a hyphen.
So what's happening here is there's two types of values recurring in the data frame. It would be self-employed and then self were in there. I did not run this, so let me just do get this column and then get the unique values of that. Oh man, it's like dots. Okay, that's cool.
Basically, it's a double. You're making two error corrections.
Yeah, so there's two error corrections at once. But it's all I wanted to show, but what happened? So let me put that out. So in this dictionary in replace, we're going to do one correction, and this correction is stated for the value that's already in the data frame, self-employed. That's the key. And then what we want to replace to self-employed is the value or the thing we want to change to, comma, next set we want to change. So that's one quick way of cleaning your data, like on the spot.
So with the cleanup, why wouldn't we take like the earlier step, and maybe this is just because you're showing us how to do this and the different things we could do. Why wouldn't we take the null employer values and change it to none or change it to NA or something instead of just deleting the whole row?
It's personal preference, I would suppose. So for me, and then also coming up into your analyses in the future of this cohort, right? Say if you have a lot of null values, you drop everything, your sample information of like say like 1,000 rows, sample being like a sample of like everything, it's gonna be like traumatically small, and like when like trying to find like observations like that, you don't have like enough supporting evidence to do anything. So that's like one caveat to dropping like a number of rows. But if you know that dropping rows for any little null value is just like a small impact to the data set, like a million row data set, and like you know that maybe 10 rows are going to be dropped and like they're unimportant. Maybe they can be important. That's like another discussion.
Yeah, because I was just thinking that like if the name value was null or the contribution amount was null or the date or something was null, then that would screw things up more. But like the employer, like if it just says none or NA, like and I still have the person's name, I don't necessarily want to throw that person's name out or throw out their address, their zip code, because that could help me like infer something, right? Yeah.
And then there's that option. And then there's also the term of what you hear like a lot in the data spaces is data cleaning. Data cleaning is the most important thing, right? And it is because of this low free flow discussions. Like you want your employer to lose that sensitive or critical information. Yeah. Cool. Let this be the end of this cheaper notebook. It's not. So here we're just replacing information, doing that quick data cleaning. And then here we just want to get the basic summary statistics of our data frame. And one row is popping up and shouldn't be, but I don't want to test that out right now because I want to carry on with indexing and all that good stuff. Yeah. Does anyone have any questions right now?
This is 1,743 donations. Is that the count of like individuals that made a contribution?
It's the count of like the number of rows or maybe the individuals.
That's not like dollars. That's like number of people.
Mm-hmm.
Does that count include the ones that the rows that are dropped?
Yeah.
So it's without the rows that are being dropped, but keep in mind that one portion of this, I didn't run through that drop NA. So that's not a actual number of the basis of the exercise.
Okay. But if we do a drop NA,
yeah,
and then we do the summary, then the summary will reflect the values without the NAs.
Yeah. Okay. And so let me go up. Like quickly do that, or actually, sorry. Let's just run all. So starting from top, it just runs, and then going down. Okay, so this is already outputted. Cool. All right, and then this is this. Okay, so there was 1743 remaining rows after that drop NA. Okay.
And then it's saying incurring the maximum contribution is $5,000. That's like it's dollars to the max.
Yeah, so it's the maximum value or the highest value that came up in that column. Do you guys know about like the 5-number summary rule, or I think it's called the 5-number summary rule? There's another word for it, but it's like a statistics kind of concept of and going to like what's known as like box plots and whatnot. It's like, yeah, so okay, like some of you like kind of know that, yeah. So I don't know, like also here we have a line, and here this line is specifically the range of like some data set, or like just say this column. Our maximum value is 5,000. 75%. Yeah. And if someone wants to like pitch in, like,
talking about the bell curve?
Huh?
Talking about the bell curve?
Bell curve is more for like distributions.
Just doing like min, max, low quartile.
Yeah.
Yeah.
Yeah, I was trying to remember like which one's min. Well,
Sorry, which one's the right?
Okay, so the 75% portion goes right here.
Yeah.
So 500. It's just that max and min. I'm like, I don't know where that goes because I know that there's also like an outlier portion.
But the 5,000 there sounds like an outlier.
Yeah.
Because the median, the 50% is only 250.
Wait, what is an outlier?
Oh, it means that the 5,000 is way above
Yeah.
the thing.
So for a specifically a column, there's these measurements I calculated here. I believe it was the mean or median. It was the median.
I think they would still be your ends. They just would change with where the box is on those ends.
Yeah.
Right?
Yeah. Yeah. Well, the 75%, 25% always go out like the edge of those boxes. Unless like.
I just mean like the way the box looks, right?
Oh.
Like if the max is like an outlier, the box would be further.
You want me to actually like proportionally
No,
show
no,
that? Oh, okay.
I'm saying you're doing it right.
Okay, cool.
Yeah.
But yeah, that's correct. You want to like also have a great representation of your data. That's very important for visualization. So I should actually, have learned from that. But coming here, back here, we have our minimum value, like down here, 5, and then there's an outlier here. I don't know if it's like that 5,000 value. Here's the median or mean. You can do some research, or I can like shoot up a Wikipedia link to show that.
It's a median.
Cool, it is. Okay, cool. So median's not displayed here, but see if
it's the 50%. The median.
cool. Yeah. Any like rehash on statistics? So here is our 25% quartile, 50% quartile is the median. And then here's our 75% quartile. And then outliers, what that is everything outside this these sections, those are considered outliers. Either are like above and below. They're just like really large, substantial numbers that are not like within that like suitable range of that specific like column. But learning more about that, and I'll etc. I can like provide resources, and like I should probably do a video on that. But that's what a box or 5-number summary is, and that's what those numbers mean. Yeah. And 5-number summary is typically used for a box plot. I think there's something else too, but man, it's been like years since I've done a statistics course. Okay. So let's go into exercise 1 for day 2. If it is not in your, if it's not on your computer right now, TAs, could you select it out, please? Thanks. Okay. I'm just going to skip this, Pandas recap, and then let's start with the group by portion. It's folder 2. If you don't have it, don't worry. I have. It will be sent out through Slack momentarily. So I can also go back if you're like curious about the directory. Kind of went too fast. So day 2 of week 4 activities, and it is folder 2. If you don't have it, don't fret. In folder 3, you'll go over your own exercise of going through and how to do group by. Okay.
Is it group by or group movies?
Group by?
Yours says ins group by, ours is
Okay. Cool. So there's a reason for that. My repository is outdated. This is a repository from back in January 2018. So does the curriculum say group by first by any chance? I could check. Okay. Let's see if I have it.
So we have something called O2 Student Good Movie.
Yeah.
What is Gatekeep?
The Gatekeep is just like an empty file, and what that does is it just whenever you try like to create a new folder and you try to like push that to your repository, it will never come up because it was never staged or committed. That is, there was no files in there. In Git, everything's file changes. And there's like the emphasis of file. So if there's no file in your directory, it's technically like not a directory. Yeah. So that's what a Gatekeep is. It's just a placeholder. Yeah. All right. I know what to do. Let me log out of this real quick. And then go to the older folder, newer folder. Right. And then what I just did there, just switched to my directory, Jupyter Notebook. Right here. It's hard to see, I know. All right, coming up.
That's what I have.
Oh, it's coming. I didn't do git pull. And I thought I wouldn't have technical errors. Give me 1 sec. I'm gonna do a git pull. Hopefully I remember my password or username, whatever. Nice. Give me 1 second. This is whatever. Oh, that's right. Server is gone, so my Jupyter notebook wasn't working. Now it's up. Let's see if I have the files now. No. Okay, cool. Okay, let's do this. Can you guys send out the second folders, instructions, and notebook with the data source? And then we're just going to go around and work through the exercise. And if you guys will definitely have questions, just ask. Yeah. Yeah. While we'll work on this in the meantime.
Which one are you doing? The one with Spotify?
The movies one.
Good movies?
Yeah, the good movies one. Yeah. So momentarily, while I kind of like resolve my technical difficulties, you guys will be given out the second folder or the second exercise, the first exercise for today, which is traversing through a Jupyter notebook. Is it good? Huh? Is that what it's doing?
Like, what are we doing? It's like, haven't we been doing this? Like,
so what you guys are gonna do is traverse through. Okay. Come over. So we are right here. His activities, okay?
And they can't do this without knowing that.
I'm just gonna throw them into it.
Okay.
And I'm gonna do one exercise.
Okay. Let's do it. So
That's what I'm saying.
Okay.
And then fix my trouble issues. Basically, you're gonna send me the whole folder.
Okay.
Or
Are you not on the Arcade Lab?
I'm gonna try. It's complicated. I don't have Git LFS. So whenever I download stuff, it comes as a crop file.
What? That's why I need Windows, bro.
I'm gonna buy a new computer, so yeah. So again, the file is gonna come out with the data source, but what we're gonna do is traverse through a data frame. And the way we're gonna do this is we had three options, or two options like I mentioned last session. One is using functions. It's look and iLook. The difference between the two is iLook is traversing while specifying the number or the row number or the column number. Look, what that does is you traverse a data frame by specifying the column name and the row number or name. So iLook is integer, iLook, ILOC, and then the other one's look, LOC. Those are functions. And In the meantime, I'm gonna probably find that exercise real quick. I can actually just go through the previous diagram and show that if too many people are having issues with traversing the notebook that's about to come up. And then there was that other alternative of traversing the data frame, which is like doing brackets. I'm using brackets and then like putting like the numbers in there, right, to get the right row number and column number. But loc and iloc is definitely a greater alternative to traversing a data frame. So,
What does traversing the data frame?
Moves around on the side.
Yeah. Because last week how you were going through columns, this week lock is going through rows.
Okay.
Okay.
yeah, that's right. So,
We're just doing the first one.
Yeah.
Oh, that's
So, because I don't want to change your local files.
Yes.
Is that true?
Yeah.
no.
Yeah.
We're asking to list the columns and we just want to top row.
So we need to get the column names.
So just the top.
Yeah, just now.
So just
So everything's working now. Are a lot of you having issues, right? Or yes, no, maybe so. Because I can start doing the conceptual understanding of look versus iLook. If not, I'll move on to the next exercise. I'll go through the solution right now.
Yeah, can we go through this
Solution?
thing? Yeah, is that what we're supposed to be finishing right now?
Yeah.
Okay.
I can go over the solution now.
Yeah.
Can we wait a couple?
Yeah, totally. In the meantime, I can show up the instructor notes for this. So let's go up now. Okay. And then hopefully from the output, we can get some understanding. If not, I can.
What is this?
Huh?
What is this? Sorry, this isn't the big. This is good movies. This is good.
It's the instructor notes.
Okay, this is not at all related to this.
It is.
Okay, so that's right. What you just had on the screen?
Yeah.
What?
Just to like not confuse you anymore, I'm just gonna take it off. Okay, yeah. Yeah, I just realized I'm like that was a bad movie. Yeah. Just give it a couple minutes and I'll go over it. Sometimes the noise is but this one I think substitute DP dot. Pandas. Do it. When you reference library, so say
What function?
you want to do the function. You're going to use every so doing the function. No. Could read underscore CSV and then try that. So you read underscore CSV because right now it's saying like which read do I want to? Yeah. So when you click read, there are 5 different types of read underscore stuff. So there's CSV, TSV, JSON.
So what I was trying to do is see that. See, I don't think
All right, so I'll carry on with the solution. And as I said before earlier, I will not have technical issues. And I say it again, I will not have technical issues. Let's hope I don't have any more technical issues carrying on. So here is the solution, and I'll go through the solution in great detail if needed. And then also rehash to iloc and loc if a lot of there's not a big consensus of like, with knowing what it is, and that is my fault. Okay. So we're going to read in the data frame. The way we're reading the data frame is read CSV with file path, right? No other parameters are specified, so everything's like defaulted, right? So the delimiter is already a comma. The encoding is UTF-8, etc. Going down, we want to see the columns.
Sorry, what?
Yeah, so I'm
You're gonna have to slow down a little bit. I think
so my head looks different than your.
We don't need to import numpy is MP.
Is this the right file? So typically you can import NumPy, but if we are not using it, it's not necessary. Yeah. So I can rehash. Okay, so here's the file path. Here, we are going to read in our CSV. The delimiters I mentioned, all this good stuff, I don't have to specify. I want the just the default parameters. And the only thing I have to satisfy to read in my CSV into a data frame is actually putting the file path in there, and then reading the CSV to turn it into a data frame.
So because you're doing read CSV, Pandas knows the field separators is by default a comma.
Yeah.
But okay, so we should. What if we have a field separator that's not a comma? We would not say read CSV. We'd say read TSV or
yeah. Or you can like specify the separation, like a.
Well, we use pipe. It says separation equals pipe, right?
So I would just add that inside.
Like a pipe delimited file. I can use the CSV file and say separate equals pipe.
So you can do pd.read_CSV and then in parentheses movie_files comma space separator equals pipe. If there is a pipe delimited or
delimiter equals
pipe.
Or no, you'd put delimiters.
Pipe is the line. It's just like
Okay. You can use that too.
Yeah, so that's what I don't understand either. So who's the separator is the field separator?
The delimiter is like that ending point, where like the end of the line.
So it's end of the line is delimiter, and then field separator is SEP. So there's
the separator is the comma.
Okay, so at the end of CSV file, there's not a.
There technically is something that's like a /n. It's kind of like invisible unless like.
But that's the same as none.
Yeah.
Why did you do read /?
Yeah, so that is the file path I want to go to. Let's go. That's not my computer. So let's go back to the directory. So here, I'm gonna go to here. So here's the good movies Jupyter Notebook. And then I don't see my file path here. I'm like, okay, well, let me still try to read in this file. Right. Assuming we think that the CSV is like right where the respective Jupyter Notebook is at. We're gonna get a file not found error. And so what resources / the file name is is the folder path, or yeah. And so if you don't have a folder called resources and you see the two files like right by each other in your directory, then just have a movie underscore scores CSV. If you have like some like miscellaneous like folder within it, then just do like resources slash. And then kind of like rehashing from last session, you don't need to put the slash in the beginning. I'm curious though if that does work. That's another story. I'm going to do Control Z to go back to the original state of that cell. I'm going to read in my CSV. And then I want to list out the columns. So how would I do that? I just do dot columns for that data frame. The data frame's name is movie underscore file underscore PD. And then dot columns, it returns a object. If you want to, in your analysis later on, turn this into list, you just call this list. Oops, that's, I'm going to get a typo error right there. 1 second. We can preserve this as a list later on if needed. Oh man. Okay. And then here that output object of the data frame dot columns, it's converted into a list. And there, if you want to quickly get all of your headers, reference that in like some other operation later on in your analysis. That's a quick way to do that. Let's just do dot columns, save it, cast it or convert it into a list, and then you can save it into a variable and then like reuse it later, rather than like manually typing out all the columns. And why did I mention all that? Because that's like also the usefulness of dot columns, and rather than just like reading it out. Here, we are going to save a reference of the original data frame with all these columns into here. IMDb underscore table, and then we're going to first read the first 5 rows. Let's do the first like 11 rows or 2 rows. Okay, there's a typo there. Not anymore. And then here, if you remember, if you want to select some certain amount of rows, you would want to put a list of those columns into the data frame in brackets. So that's why you're seeing double brackets right now. And then as also a side note, make sure your spelling is correct. Or else you get like a type of error, I think it was a syntax error, or cannot read some column error. And the reason for that error is there might be a little typo, like maybe something like lowercase. Okay, so here, Loke.
I know, but I don't want to just see the salt file. I want to go through it.
Yeah, let's do it. IMDb table, that's what it's called, yeah. So we have all of these columns in like, several rows, right? So I want to select these first 2 rows, first 2 columns with all rows. Let's do that. Dot iloc bracket. Bracket? I think it was bracket. Let's get all the rows, comma 2, 0 to try that out. I forgot. Right now I remember. What's happening here is for iloc is we want the location of some subset of our data frame. We want like some smaller portion of our original data frame. And we get that by getting all the rows. All rows, what you'll do for iloc and loc is just a colon, comma some amount of my columns. And as we all know, something comma something is rows comma column or columns. So all rows comma, I want everything from the first row up into the second row. Column. Long day. Long day. So again, all rows, and then I want everything up until the second column. And then let's just get everything from this data frame using iLook. So here we need all rows and all the columns. And now say I want just these last two columns. So I want everything from the third column and after with all rows. Yeah. Let's run that.
So indexing doesn't start at 0, so indexing starts at 4, 5, right? Is that why you said 3?
Yeah, that's what I'm getting.
Yeah.
0, 1, 2, 2.
And the reason why I put a 2, the reason why I put a 3 instead of a 2 is because I wanted, it's kind of like weird, right? In comparison of knowing, like, usually our elements start at 0.
Yeah.
Yeah. Position. Here, when using iLook, we get everything at like that first position, like after. That's how the count is. And sometimes if you don't remember, don't be afraid to run the command and just be like, okay, like, oh, I referenced the wrong amount of elements. So here, all rows, and we want everything from the 1, 2, 3, third row, everything after the third row.
So why did you do 3 colon instead of colon 3 like you did colon 2 before?
Yeah, so the reason why I did that is because I'm like, I don't care about this stuff. I care about this information.
So then it's going 3 from, so it's like left versus right. Just colon.
Yeah, so everything to the left of that.
If it's 3 colon, it means 3 and afterwards. If it's colon, 3 colon 4, it means before the colon. Yeah.
Exactly.
Okay, sorry.
It's cool. And then
Is it possible to call on column if I still wanted the film title, but I still wanted columns 3 and 4? Like, is there syntax for that, or is that not allowed with this?
So with this, it's not allowed, but with Loc, it is allowed. I'm gonna just experiment with the rows real quick. Yeah. So I want just the first 4 rows, and then I want, if you're making this confusing, I want everything from like in between like that second and fourth column. So let's run that. This. So let me space this out as well. I think that's good enough. So I want, for my rows, I want the second row up into what I thought would be the 7th row, but when that endpoint is never actually reached early.
It's not inclusive.
Yeah, not inclusive. There you go. It's not inclusive, so we have 2 through 6 for our rows. And also, this isn't from the first column and thereafter. It's from the second column up into the 4th column inclusive.
Why the row starts from 2? We have 0, 1, 2.
Yeah.
We want.
So I wanted to get a subset of some information. So say like in one particular, for the whole, so let me get this out real quick. Or actually, let me get this out. I don't aesthetically or like visually, I don't want to see like a lot of information. Say if I'm like comparing things from an eye perspective visually, right? I just want to like scope in, zoom in, like look at stuff. So I want to like see the subset of information from my data set, which would be like right here, because I think something's happening. I don't know if something's happening, but I think something's happening. So the way to like easily like, go through and like get that piece of information from my data frame, I can just do iLook and then like specify that range for both the rows and columns.
No, I mean like
sorry.
You're starting from the second row. Why is it second one? It should start from the first one. It's like it's starting from 0, 0, 1, 2. If you put 2, it should take the first row, not the second row.
Yeah. So it just justifies the fact that this specifies everything inclusive. So everything in between 2 and 7, not at 2, in between at 7. Yeah. Like I thought originally. And then like don't be afraid to like test this out. Just like try it out, see what happens. Like if like you didn't get like the right reference, you're like, oh, okay, just do a little bit of correction or readjustment. So now let's go through and test loc. Here we want the location, but we want to specify the rows or your indexes specifically. And then our columns, but the way we're going to call our columns is not by like numerical values. It's going to be through calling it through the actual titles of those columns. So again, iLoc is a way to traverse everything into data frame using like numbers or like elements or like those index numbers. Not index numbers, but elements, numerical values. Here, loc, just take out the I. We're going to traverse through our data frame, through the index, the actual like title, like our names of those indexes, and then the actual names of those columns. So let's film columns names. Fail, so it doesn't. So what happened here is we get the those few rows for just the film column, and then we want all rows for the film column. So we just type that in, and here we are. You can also just do to just get one whole row in its entirety. Just do this like you like we've kind of like typically seen in these sessions. So that has the same output. So there are different ways to kind of like traverse through a data frame. Another key thing of why we want to use iLoc and loc is say we're doing our data cleaning process and we specify elements without iLoc and loc, and we want to overwrite those specific elements by what's something you guys will learn later on is like a lambda function, like a random function, if you will. It's like less complicated than it sounds, but what happens when you do like some operation and you try to like overwrite specific rows or columns, and just those specific ones, it won't actually overwrite. So to actually overwrite the information, you would need to use iLoc and loc and specify those within like maybe a for loop or something like that to overwrite that information. Yeah, and then if you guys, if that's kind of like slips your mind, don't worry, you might like come across that situation. Just remember, if the information wasn't overwritten, it was because technically there was something like was kind of like incorrect in like trying to reference those specific elements. Just have that in the back of your mind. Okay, and so the exercise, the solution that you guys are working very hard Sorry for making you guys go through that. So here for our data frame, we want to partition out, right? So I think we're going to use loc, and we want here. What's happening right here is it's a series of all Boolean values, Boolean or true and false values. What's happening here is for IMDb, if a score is greater than 7, it is true, not then false. And so, yeah, okay. And so, let me actually just show that out right now, actually, because so let's get that right here. Here is that series. Now let's put a condition statement on that, on itself. Right now we just see those all those values right now. We have a Boolean representation of them based off is every row greater than 7. So we just do Control Z or just delete it. Yeah. So all that, I'll do that. So all these Booleans right here, and this is being put into those rows. Oh, that row section of the original data frame using loc. And so whenever something is true, we're going to get that row only. Whatever's false is neglected. This is another powerful way of looking or observing into your data without having to scroll up and down and compare values visually. Okay. And then what's going to happen right here is for loc, remember, we don't want to specify our columns after that comma or column by 0:7. We want to have either just the column header or column headers happening in that portion right there in loc. And then let me run that. And that is the output as you just saw right now. Any questions on that part?
Can you go back up a little bit? I saw that value was asking via Boolean values.
Yeah. Okay. Any other questions on this part? And I can test it out as well if you guys need me to. So here, let's get the first 10 rows with those specified columns. Oh, that's not there. Why is it not there? Oh, because I know why. That's why. Cool. So what I did here is I changed that whole conditional operation in the rows. I just want the first 10 rows with these specific columns, and then just show that. But coming back to the idea of, I want all the rows that have IMDb greater than 7. And let's run that without this head operation. Here we have 0 through 10, and then we see that there are values greater than 7 for IMDb. Let's run that. Is that the right IMDb? Yeah, it is. Oh yeah, no. Sorry. So now we have all values, all rows, all the first rows that have everything with an IMDb score greater than 7. And then I actually anticipated right here the indexes to be like 0, 200, 201, 202, 203, like some those selected indexes. But what happened here in this operation of .loc is we got our subset, but the index here was like not resetted, but as like a fresh new index, as opposed to referencing to the particular.
Okay, it looks like this reference is 01258. This is going anywhere.
Cool, yeah, it does. Okay, cool. I was like, I'm sure I've done that before. I'm like, why isn't it showing? Thank you. Okay. Questions on that? Let me go back up.
The Boolean values obviously can go like greater or equal to or operator.
Yeah, so let's try like not equal to. Oh wait, no. Well, that doesn't make sense. Oh. So yeah, now we have like values that are not equal 7. It's observed right there. Okay, let me carry on to the next portion. Here's kind of like that same similar operation. So we want, using loc, we want these certain amount of columns, film, IMDb user, vote count, and we want everything where IMDb user vote count is less than 2,000. And that output's right there, so let me switch it to greater than 2,000. Wait. Cool. Oh man, that was almost on time. Okay, so here we have all rows where that user vote count is greater than 2,000. And then we have like those like indexes respective of those rows. And then here, I didn't mention in the last class. So like read_CSV, there's the counterpart to that, which is outputting something as a CSV or outputting it as some file type. So for this data frame, we want to put it to an Excel file. We have to specify the file with its proper suffix at the end, or like at that ending portion. The file type with the indexes being false. What that means is for this parameter, do I want to preserve those index, or do I want to have? Pretty sure it means to have those indexes right here as its own rows once exported into this Excel file. Let's find out right now. So let's go. Let me bring up my folder real quick. What folder path is this? Documents. While I am looking, I hit tab right there to auto-populate the data frame, to hit tab, and here are my different options. I can export this to a CSV, JSON, HTML file, and some other file types. So that's what I mean by those, like there's like other alternatives to outputting a data frame into a certain file type. Right now, I am looking for the Excel file that I just outputted. Does anyone have any questions while I look? So here I have the output. Okay, output file, movie watch list, that Excel file, and then here. Okay, so when index equals false, we don't have the index become a row, or excuse me, a column. Oh my gosh. So let's put that index as true. Back. 1 second. And then here we see that when index equals true for 2 whatever, we get that index as its own column.
Oh, when it's false, it doesn't get its own column.
Yeah.
It just resets. Like the index.
Yeah, so that index isn't treated as its own column when it's exported.
When it's false. When you.
Yeah. Okay, so let's carry on to.
Can you show me that parameter one?
Yeah. Yeah. Index equals. Yeah. And then let me hit Shift Tab. Let's just Shift Tab. That's something I've used before. Maybe the headers. Maybe like sometimes I want to export the file and I don't want the headers. Maybe I do want the headers. And how's that use case? Say I want to rename my headers in a different a project, or I just want different headers in a different project. I can just, instead of having that information like preserved in the CSV, I can just like neglect it. What else have I used? Encoding. It depends on like what that your specific user case is when using these parameters. Okay. And that was 2 underscore something. Hit tab, and you'll be able to see those list of options. The popular one you guys are going to use is 2 underscore CSV. One we've been using recently is read underscore CSV. All right, so let's go through some data cleaning. Right here, looks like we have our same. Let's see if this is the same.
That's the same.
Huh?
That's the same.
Oh, cool. Get to skip it. Cool. So the first exercise I went over in the beginning class, I've already covered it. Does anyone have any general questions right now? No? All right. Let's go on a 15-minute break. Back at 8:17 or 15. In the meantime, for those sticking around, any questions? Or would you like me to go over something? Or the TAs as well. They can help out. All right, chill.
To Excel file.
So it covers
Also, yeah, right. So normally we like
It's not tedious.
that's it.
I don't know. I didn't hear about that.
Once again?
Is Tom coming back next? Is Tom to play back next week, or is he sick, or what's going on?
I don't know. Usually Alex just asks me, hey, like, can you help out? I'm like, yeah. So, but I don't actually ask.
We don't know what's going on with him.
No, but I can assume it's just like end of the quarter. So like, and he's an engineer, so he's probably having like a good time at work with like end of the quarter deadlines. That's my assumption, or maybe he's sick. I'm not sure. Yeah.
So nobody knows right now.
No, I can ask or something. If I see Alex, I'll be like, hey, like, where's Tom? Yeah. Yeah, usually I just learn not to like ask anymore. Yeah, I'm just like, whatever.
I mean, it'd be good to know since we paid a lot of money for a class and if our instructor's not here, it's kind of frustrating. Not to say that TAs aren't qualified to teach, but you know, spend $11,000 on this.
My heart. Yeah, I don't know. We're all human. We all get like, yeah. But yeah, it is good to know for sure. Yeah, love and time. Anyways, any questions? No. I can talk about anything, by the way. So. Sorry, man, was falling.
Yeah, so
Mexico's false, right? I don't know which one. False. Yeah. With solutions. We're opposite. Try it first. Yeah. Okay. That wasn't able to write it. I love use numbers because fucking long but that's it. The row numbers, the column numbers, yeah, but whoever you love gives an animal the row yeah, so I've had a whole row and whole column.
Every single double all his matches.
So I think everything is by the instructions. So here you have solved example. Oops.
Oops.
So my screen was showing that my and no one, I feel like no one wants. Yeah. The only one has the audio. But I guess.
My question is, how
I don't have anything. What are you talking about?
There are some now. So
No, it's not CD.
So that's probably not obviously. That one was the only one.
I think maybe they have some issues.
Okay, you're still here, so I would assume you did.
Okay.
It's just like one round Excel.
It's like probably just something crashed out.
Yeah, right. Okay.
There's a
You might question forward, how do you find them? Well, I can come. I think this,
Reinforced part of that.
Why am I here?
Well, we can use Citrix. So then your CBS is no.
I'm going to take the capital.
Yeah, I would actually like to do that one.
So do you guys feel like ready to pair program for about 15 minutes? Or you guys still want like 2 minutes left? Okay, for sure.
Pair program.
Or just go into pairs and like, yeah, together and like work. Sorry. Oh, okay, yeah. Sorry. Like,
Is this like a new function or something? Pair?
I have a friend and she at her job she like pair programs all the time because it's like encouraged for like first year engineers. Yeah. So I'm like yeah. So it's a great way from like collaboration like when like in engineering just like working on creating like some software or like whatever. It's a great way. It's like it's a practice. Yeah. I've never actually done it, but like. Yeah.
Are we doing the search for the worst? I don't have that.
I'm gonna send it out. Yeah. I give up on that. I give up. I had the same issue too, and when I did, my corrupt files came up, and then I was like, okay, I'll use this other folder I have in the past. That didn't work out. Folder. Let me all right. So let's start with 15 minutes of going through. Everything I'm sending out right now is the Jupyter Notebook, the CSV file perspective of that, and then also the instructions. So yeah. Pair up, or you can work by yourself if you.
You're sending us something that's not already like in any of this, so like we don't have what we need already. You're sending us something new.
Yeah.
On Slack.
Yeah. So this.
Please no. It took us so long to get the other files.
I'm shocked that you guys are this disorganized, but it's okay.
I just yeah. For some people, GitLab's not working. So here I sent out the Portland Crime Jupyter Notebook, this CSV, and then right now I will send out the instructions. Let me also put it up here as well.
So there was a Portland crime folder that I pulled from GitLab. That's different than the one.
It's the same one.
Okay.
Yeah. If you were able to successfully do the git pull, then use that. Use the files within folder 4.
Okay, so if we pull again from GitLab, you put these. This is like I don't have a README. I just have an unsolved. Or sorry, I don't have this solved. So you're going to show us. We're not supposed to have that. We're supposed to have the unsolved version that we got from GitLab, and that's what you're about to open. Okay.
What is that? Here it is. Cool. And then I'm also going to put it on Slack. Poor font. you have any questions, let us know. Me and the TAs. Cool.
But we're not actually dropping, are we? Because it's saying define them.
Or then it'll drop the zero.
Okay, so the first part defining them. So
Yeah.
look for missing values. How did you look for them? So you're just
You're
coming for empty.
You're coming from
Missing
total.
values. So what
When
about
you
that
say
is missing?
find
And that says look
find
for
null
missing
values.
values.
Right.
So,
Are we looking for the rows for the null values?
Was it NA?
Just looking at the
okay,
logic.
so
Yeah, so find the rows with like null values.
So from my understanding.
It's null, right?
There's a
Yeah.
there's a bunch of 4, 1, 2, 3.
The way that's done is
So those are
Because
like
dropping is
full
dropping.
rows. These are-
We have to find it first.
and looking
Yeah.
at the head,
So,
it makes sense that
to
they're-
find that. So it'd be data frame,
So I'm assuming that.
So column is
We want all column.
Huh?
We want every column, right?
yeah, but you want to find the null values of.
It just says find missing value. You say which column, it just find missing value.
Okay, let me think about that.
You want to have
So,
delete row with any
Yeah.
missing column or?
are we cleaning that much? Or are we cleaning more specifically?
I would say just drop any. Yeah, and if there's a substantial
We wanna
amount,
Find it first though, that's the first step is,
it's when it says look for missing values, it doesn't say delete them, right? So
yeah, we need to find out which rows have it first.
okay.
is it telling us to delete them? I mean, I know, but what are we supposed to do here?
But yeah, what is?
I would do the value counts. So of those counts,
I mean, it's just printing out like how many there are of each column type.
Yeah, I mean, when someone says look for missing values, that's not what I think of on an
Yeah, exactly.
account.
No, it's not, the comments aren't helpful.
Like there's like an is null in Pandas. Should I be looking for is null and printing that out somewhere?
let's try that out. Yeah, seems like a good alternative. For the whole data frame. Yeah. Is there like are there different amounts for every column? So
So I'd assume that the highest value have the
But we did
number
express that, but okay,
yeah,
entries, right?
Yeah.
Anyone and any row, any column that has less than that would have the null value.
it contains nulls for that specific column.
Okay.
And that's all you need to do for now for like finding the like.
Oh, so that's the only.
Yeah. Like specifically don't go and find the row like what rows are null because that going over finding information based on like conditionals we haven't talked about yet. But you guys have like the right idea.
So
For sure.
So that's good enough for now.
Yeah, dot counts. Yeah.
So just to verify that.
Because that's what we've like learned so far.
Okay. So once we remove the null rows, we should have the same number of, all the columns should have the same number.
Yeah.
Yeah, because you're like for any, you're literally like extracting out the rows that have nulls, and then what happens is as you do that, all columns respectively have the same number of like rows. And then what you'll do is you'll say the data frame equals that same data frame dot drop NA.
Yeah.
Because we want to overwrite. Yeah. I can just like also go if anyone has questions. I'll give it about like another minute. And I'm gonna like start it.
Yeah, so that's the house now. So that tells you in the data frame which form of data is needed, right? As you can see. 50,000. You want to find exactly which column for which column you can use the value. That's the that's the next. You can select out 2,000 points that are needed. That's a very focused column and row calculating values. So what you do is to sum. This means sum is all values like true or false. True in that case, they're using true or false. Sum this, so sum equals as by column. So it shows you which column how many values.
True, then this is no value. This is no value, right?
So it tells you like yeah. So true when you solve the true.
Yeah, this first two is no.
Choose one and false. So when you add false, then you add without them. So that's general idea. That's when true or false are converted to numbers. Choose 0, choose 1, choose 2. So there's not a which
columns have no value.
Pandas. And do
So the address has a no value. Case doesn't. My case doesn't. Okay.
So I forgot the exact.
No. That's good.
And then you should zeros.
All right, so let's get started with going over these solutions. Brief bit in the resources channel, I put some of the commands that we have seen over the course of tonight. If I'm missing anything in that resources Slack channel, or if I'm missing any commands, just let me know and then I'll make the proper edits. Or you can also contribute to that conversation to help out your friendly neighbors. Let's get started. Importing the Pandas library. We're going to read it in, and then we're just going to get the first 5 rows of our data frame. I also put tables, I forgot. Cool. And then now we're going to look for the missing values. Okay, cool. All you need to do is just count of your data frame. And so as I run everything, I should get the answers. But regardless, here we see quite a lot of occurrences of 41,032. So I can assume that's the maximum number of rows in data frame. Anything less than that, as Rosa pointed out, there is some missing information for those rows, or there's like null values. And so now we want to drop those null values. Like I said, there's 2 ways you'd want to tackle this in your analysis. You can drop all or any row that contains a null value, or you can do some pre-processing or some data cleaning first to replace those null values. And one way we can do that is
Go NA.
That's possible? Yeah, cool. I didn't know. Fill NA. So there's that function. Here I would put like replace some column and then like overwrite it. And for the bad value, we don't want, or just replace it with and then log cases, if there's like no values in a numerical column, you just replace it with a 0 or overwrite that null value or NA value with the 0.
Null should be out of the, null shouldn't be enclosed in the
Here?
in colon, right? So null is not a string. So there's the null
Yeah.
is not a string, right? In the
Oh yeah, you're right. True. So null value is an object or a data type, not an actual string. But there can be strings called nulls. Watch out for that in your in simulated cleaning. You see null values after you do some manipulation of your data set, and you're like, okay, wait, why is this say null? Even though I take out the null values, then it could be literally a string called null.
I have a question
Yeah.
with the overwriting with 0.
Yeah.
Because if we're going to get the stats number summary, if we have zeros, then would that push the averages down because
Exactly.
of the 0 values?
Yeah, so that's the caveat of that approach, is straight up replacing all missing information with some certain type of information. What that does is creates misinformation, right, in your statistics. So there's many ways to kind of go approach and kind of do your game clean process. I don't know any open source libraries that kind of help you out with that with respect to working with a Pandas data frame, but I'm sure many people have open source or push their stuff to GitHub on giving out a function or how to easily clean your data set or a class to clean data set or their own open source library. They're out there. And so we are gonna drop all these values. Now we're gonna get the count. So now we see that 41,032 rows at most is now decreased to at most 36,000 rows for our data set right now. And then here we just want to get the value counts of some specific column. And here in the analysis, you want to check to see if there are any values with misspelled or some of the values equivalent to a fence type. I don't see it. I should scroll down.
I have a question with that.
Yeah.
Why do we do a values count if we want to find if there are misspellings?
Yeah, so how does it check for misspelling this language?
So it's not checking for misspellings. What you're doing is you're grouping all those distinct or specific or unique words. You're getting the count of them, and say if you see a count of 1 that says the incorrect name,
But you could pass it through a spell checker.
There could be an open source library for that.
So it's just telling you to display the offense types, not to be misspelled.
Yeah. Well, right now what we're doing is we're trying to see how far the values, if there is that misspelling, or any misspellings, and that's just by simple observation and analysis, right? To automate your analysis, you can have a spell checker module or create some function to do that. But in literally an analysis, you're doing research and doing this investigation, forensics. We'll put out a random word on your data set to get that to find some potential hypotheses. So, okay, so I don't know if there was a fence type in here. Let's find out. I don't see anything. We'll find out. So I guess not. What? Okay, cool. So carry on. We want to just replace some certain values in that column and properly spell them or characterize them, if you will. So an example for this column that we're referring to, we saw that commercial sex acts is essentially prostitution. So why don't we just relabel that, right? Let's do that. And the way we do that is for this replace function, we're going to put in a dictionary. This dictionary contains, again, key pair values. The key in this case is where you would the targeted value that's already in your data set and how you want to relabel it. And then we're doing this for 2 different types of words in that column. Wasn't that good?
Sorry.
With a warning. Is it a deprecation of the library? So what we have for our data frame is a reference, and this is like one case where using loc or iloc is important when you're trying to like do that data manipulation that I mentioned before. In the case of like using the lambda function, like I mentioned earlier, you guys will learn that, I believe, either in the next session or next week. What a lambda function is you do some magical operation for some data frame or data set, and like some result would come out. But in that case, sometimes for me, when I have done that without using loc, like do these kind of steps that we just saw now, dot replace, my expected results wouldn't happen. So that warning is just like saying, oh hey, like heads up. It's preferred to use that type of method. Yeah. There's a warning similar to this. And that's how I found out all this information that I'm telling you now. It's because I came across it and yeah, how to deal with that. So now we want to locate everything in that data frame where an extra bracket. 1, 2, 4. Let's run that. Oh. Where's the second? Oh, there. Okay. So we want to locate everything where no crime. Our data frame, the neighborhood, has is only equal to Vernon. I'm saying it right. And so let me show you what that specifically is. So here we have a column result of true and false values. So we have for our neighborhood all these names. Are they equal to Vernon? Here we should see false, false, true, true, several falses. So that result comes out. Excellent. And then we put that result in here, and then we get an output of all the rows and columns respective of that condition. You can also do, instead of .loc, just this. That's another notation that I've used as well. And then remember, loc is where you'd want to locate something in your data frame using the specific index name and column names. iloc is for integers numbers.
And without them, LOC is what?
Without it? Yeah, so you still are able to look through your data frame with that same condition. It's just that loc. Remember, like sometimes that might play as a key factor in like doing in some portion of computing either series or your data frame. Yeah. It's That would be the benefit there. It's a specific like corner case though. Like, but remember, have that in the back of your mind. If you're like wondering why something doesn't come up, try using iLook or look. Any other questions?
Can you go back up? I want you to replace part.
I'll go there first. What?
Oh, can you go back up to line up? Oh, go down a little bit, sorry.
Sorry, yeah.
There you go, thanks.
Yeah, no problem.
You're not gonna-
Yeah.
Is there a way to change the sort order? Like if I wanted to,
So the values?
yeah, if I want to look at crime against property. Alphabetical order on that column.
Yeah, so for that, you do dot sort. Maybe dot sort underscore values. And then you would specify how you want to sort by your data frame or subset of your data frame. So just get it by what you want to do?
Oh, it's just asking.
Okay.
So
Okay.
it's
Yeah.
dot sort.
Yeah. Dot sort values. And then in your parameters, shift tab or return tab for my user. And then you'll get that. And tab for the additional documentation or docstring with examples. Cool. And then there was another question. Yeah. Cool. Here?
Yeah.
Would you like me to?
I see why mine's not.
Oh, okay. Well,
Go off a second.
okay. Well, I'm happy to troubleshoot that with you guys offline. Yeah. Yeah. So let's continue on. Or maybe one of the T's can help out right now or later. So let's go into the group by portion here. I will send this out after I talk about it. So group bys. So in SQL you have your so you have a table in SQL which is like a universal kind of like way to go through and traverse through a data set. I'm just kind of bringing a brief overview. That's not the technical definition of SQL, but there's a command called group by. So in your data set, you would have some IDs and then some other values, and then in these IDs, you can have multiple occurrences of the same ID. So person one has like ordered something twice, and then only one person came into the store once, and that person was their ID or transaction ID was like number 2. Their ID is number 2. And so what group by does is we're able to group by the specific information and then do an aggregation or kind of like some like mathematical operation on them. And typically what that is it's like a sum, count, min, max, etc. That I can discuss with you guys offline, or you guys will come into it in about SQL concepts and all that related information. But we'll also see the kind of conceptual ideas kind of like right now. Okay, so let's go through that. And then we're going to read our CSV, data type warning. Well, it's a warning, so I'll ignore it. No, I shouldn't. Okay, and so here, .drop NA, how? You do any or all, and then, yeah. And then here, after doing that operation, we then verify that we have no values by doing that. Okay, here, some additional transformations. And throwing out one word or acronym ETL, extract, transform, load. So right now we're doing the transformation after, say, we extracted this information. And yeah, we're going to like load it later on and for analysis. ETL, extract, transform, load. That's the pre-processing into an analysis for a data analyst, data scientist, data professional. And also probably link it. Okay, so here we're traversing through our data set. And how we're doing that, where we can either do .load or just have the, removing this, just having the conditional statement and brackets. Here, if we would want all columns, we can just, have this right here or this output right here. The conditional statement, or we can do right here to get the same expected result, which is I want all the columns, and then for all, I just want the rows that succeed with this condition right here. So running that, get the same output. Bring it back. Cool. So running that, the same output here, .value counts for some specific column. Let's run that. So how many signs have occurred within each state for this UFO data set? And then here is a breakdown of the occurrences in that column. Here's the kind of like the equivalent of group by, and it's also mentioned offside in the section last session. So what's happening right here is for all those values, California, Florida, etc., they're all being put into sections, and then for the section, for the collection of all these sections in each bucket, we're counting them. How many of those values are in each respective bucket, getting this output. So it's kind of like the same process as a group by. And now we just want to use the group by function for our data frame as a whole. And we want to group it by state. Seen above there. So for our data frame with a specification of the column state, what that does is we're going to get like the whole data frame itself. Dot group by, we want to group by one column. Here by equals none, so we have to add something in there. That be state, and then I'm trying to find where the aggregate. Okay, there's no aggregation yet. Okay, cool. So we're doing the grouping, and then here the object is returned as a group by object, not a data frame object. And so let's first view those first 10 rows. Here we have our original data frame. And then down here we have the grouped states. And notice how these states are now our index for this group by object. And then we have the collection of all these buckets for each respective column, respective of our grouping. Here, you'll see the metadata associated with your group by. It's a group by data frame object. Say if you now thereafter want to save this in a variable, save this in a variable, and your assuming your instinct is to do some like operations like describe or anything like with a data frame related function, it won't work. You would have to convert the group by object into a data frame to be able to do those data frame operations. And what I mean is grouped USA. That's very bad. I don't know. I'll just leave it like that. Equals PD dot data frame grouped USA DF, and now we'll convert it into a data frame for it being that grouped by object that we just had. But that's just a little side fact. So here for this group by object, we want to do this aggregation or mathematical count. Specifically, what we're going to do is we're going to just count the number of references like you saw in value counts for all columns. The output's there, the first 10 rows. Any questions on anything I just mentioned? Okay. So here, for a grouped by object, which was saved right above here, right? So we never specified an operation. So what that does is, again, the group by object is saved, but we never done the aggregation, which a group by, like does. It's, yeah. The intended use of a group by, and we never done that. So we saved that, and then we consistently use the same reference, and we do a count. And then for that reference, for a specific column, we now do the sum of those values. And since it's numerical values, duration seconds, they will all add up together. Sum is like something plus something plus something. And see here, our index are the states. So for all these states, what are their total duration seconds? Okay, and creating new data frame using both duration and count. So now that we saved this information, specifically the count. Yeah. Oh, no, it's not the count. Okay. I guess it's not doing that. So right here, we saved that summed information here. And then now for this group by object, we're going to turn it into a data frame with some other column, which is state counts. See it above. So here we have we're creating our data frame for a dictionary of lists. Here are our keys. And then our lists are state counts and state duration. State duration is the aggregation we did up what we did before. And here we have our summary table, or think of it as like pivot table. Yeah, Excel. You guys know that. Okay, cool. Any questions? It's also possible to group a data frame by multiple columns. So what that does is for our data frame, we not only have one index, but we have like a secondary index, and then like some sub counts within this object. So here we're first grouping by country. So everything's collected together in separate boxes by country, and then from in there, there's like boxes within those respective boxes that are being grouped by state. And then within within those inner boxes, we do a count. of all of that. And that count is being shown for every state line or row. Does anyone have questions on grouping by two columns? Cheers.
So for when we have two things to group the whole data frame by,
Mhm.
we only get the counts for the combination. Let's say I want to do a count for the country. I don't do it by country state, I just do it by country.
Mm-hmm. So by country itself, you will have the total of all this right here.
Mm-hmm.
Yeah. So it'll be like.
So is there a way to get some summary for the country in this scenario?
Oh, in this scenario?
Or is that going to complicate the data?
So I would say you can do it. You can do another group by the column itself and like append that column into into like a new data frame and get like a the table.
Okay.
Yeah. And here, the same idea. So we're going to convert a group by object into a data frame for total summed values. Let's do that. Let's define, awesome. Let's define it. Again, we create that data frame. And there we go. And then here, when creating this data frame, let's see if I can reset the index at this portion. Say if we don't want those indexes of like country and state, we just want like 0 through etc. I can either do like the data frame dot reset underscore index. Let's see if I can. Okay, I'll try that out. What's my data frame's name? Group by national. What did I just say? No. PD.reset index. What's back? Okay, let's reset index. I don't know what way, but there is a way. And if there is a way, if someone can find it, slack it out in class or let me know right now. 1, 2, 3, 4, 5. Okay, no, cool. I'll find it soon. So now, can I have you guys for about 15 minutes go through this folder 7, pair up together. It's a Pokemon data set. Going through and doing analysis, but using the conceptual idea of group by. If you don't have the information, the TAs will slack it out right now. Do you guys want to slack it out or me? Oh, you guys got it? Cool. Just a minute, yeah. But in the meantime, any questions on anything at all? Just in general, like recaps. Oh, cool. All right. Stay tight. That was horrible steady music. Okay.
The first time I experienced virtual reality, I remember this very well. You looked at objects, you went like this.
Okay. Okay. I was pin like very low. Kill the white. The black and noise or whatever the word is.
Are you the resources? Yeah, resources.
File. Yeah. Or if you want the rows, yes, whatever you're defining. So same thing. Seems to be fine.
Cheers.
Can you show us the command for extract? How do you extract it? To extract the columns?
Oh, so like loc and iloc?
Yeah, how do you do that?
Let me pause the audio. Yeah, so let's go up here for this data frame. Did you want to get a specific column name or?
Yeah, specific column name.
Okay. Nice. Let's get city. So I want to do dot loc.
What is the first state duration? What is that? That's the first part.
For what?
What is state duration? That's the file name?
The data frame name?
Data frame, okay.
Oh yeah. So yeah, I believe so. Yeah, it is.
Okay, sounds good, yeah.
Well, actually, it's not. Let me get the original data frame name. Good catch though. Okay. And then here, I want. Do you want all the rows? I'm gonna assume yeah. You want all the columns or? Okay, cool. So I just want city, right? So I'm gonna do dot loc colon, and what that means is I'm gonna get all of the rows. If I want the first 10 rows, I'm gonna do either, this is kind of implicit, 0 to 10, or I can just do colon 10, those first 10 rows. But I think we want all rows here. So all rows, and then just city. And then here are all the rows for city. So let's try that one idea again. 0 through 10. And we get the first 10 rows of city. For specific, do you want me to go on, or was that good enough?
Hey, that's good enough. I'm just trying mine now.
Awesome. What? Do you need help? Or?
So when you refer to the frame, you say the frame name, the underscore df.
Oh, so for that, that's the name of the data frame, right? Okay. This is my data frame name.
Yeah, dot loc, right?
Yeah. Maybe in your case it's like df.loc or loc.
And data frame is just a file. It's like that. So I take the known file and named it as the CVS and named it as a file. So my data frame becomes a file, isn't it? Not really.
Are you doing 2 CSV?
Yeah.
I'll just go. Yeah.
I have this file, I refer to the source and then I put it. Yeah, so it locates that file, and
Then my data frame is your file, right?
is it? Exactly.
Here, I can
Just switch it up, yeah. So what do you So looking right here. What does it mean when it delays? It means it never ran. Okay, it's that yeah. Now it's the fifth one. And yeah, you can go proceed now and load it in right. And if you do that head, you'll be able to see it, or you can just do Pokemon.
What is this between the rows and columns? What did you find that? Is it a comma or just a comma?
So
Just a comma, rows, all rows, comma?
sure. So you have the list right there, right? For the columns.
Yeah.
So what I'm saying is, I want all the rows, I want a column, then another parameter. So I'll put this in parameters there. And close that. Subtract it.
Okay. I have that.
And one more bracket at the end. So we need another. One more time. The auto fills. Like third. And run it.
What is this?
The auto fills.
Should I take this out then?
Yeah, just take them
You
out.
just said that
One
twice.
and run them.
This is what again? Oh, yeah, I got this. Well, what is this, all this then?
It's a one.
What do you want that for?
Yeah, do you have a missing label? Passing list links to the link or.
I mean, got all, it gave me the right answer, right?
Yeah, so is that, what version of Python? The 3.6?
3.6, yeah.
Either you got 3.5 or 3.7. I don't know, I'm just throwing it out, that could be a possibility. The warning, yeah, just ignore it. Just ignore it.
So the average tax is described as parentheses, right? Described parentheses.
Let me bring it up, those dots on for your group object. Where'd it go? So the group object dots on equals parentheses.
Your question is, do you create a data frame for that which stats?
So here, yeah.
Okay.
You had it ready. Create a data frame for
Oh, okay.
Are you-
No, for that bracket. So you still want all the rows, right? And it should be typed.
Yeah.
And you want a list, an array
Yeah.
of all the columns. So you need close because that's green, because that's just big room. So I have all of them right. Did you read it?
I average it.
Just to kind of really see what's happening. Because for country, when one codes all comes together, it's like the first year by.
It's not necessarily like all species.
Yeah.
DF average isn't really an average, it's just a.
That's just
That's just what we call it.
So we have about 9 minutes left. I'm going to quickly go over this exercise, and yeah, we'll call it a night. I think it's Wednesday. Oh man, is today Wednesday? I'm a day off. Yeah. This is what the week does to you. So let's carry on. And then the last exercise, as you saw down there, solutions will be sent out later on, but it's just doing dot sort underscore values that I kind of mentioned earlier, but I didn't execute. That's the conceptual idea happening right there. I feel like this is more important. So we're going to import our dependencies, read in the file with the right directory, resources slash Pokemon.csv. And so now we just want to show a subset of our table. We could do dot loc colon comma with that list originally right here. For all rows in those specific columns, we can just have this operation right here and it'll work just fine. They're both equivalent. Yeah, equivalent. Cool. So we have that output right there. And now we want to create the group by object based on type 1. Oh, that's what type is. Oh, grass and fire. Okay. I haven't played Pokemon in a while. So yeah, it's a random fact you don't need to know. Okay. So here we have our group by object. And I say group by object because we're not doing some type of aggregation. Okay. So the group by object is stored into here. And then that now is we have, excuse me, we're going to do this aggregation right now. Say if we didn't have that variable, we just want to do a straight group by operation. We could have just done this as well, and it would have been great. Why is that first method more preferred? First method being saving the group by object into a variable, then doing an operation. It's because in the case of, say you want to do different types of operations, and you don't, for the sake of computation, you don't want to keep on doing those computations over and over again, as you've seen right there. You save some time in your script or your Jupyter notebook. And where can this occur? Big data. Okay, so let me revert all that, run that. And so here we have our group, are the means all grouped together by type 1. And then the average or mean is shown here for every respective column, and then also for types.
Do you mind going back and putting that code back up again?
Which code?
The one you said we shouldn't use.
Yeah. Yeah, definitely. Doing Control Y. Yeah, right here on that cell. The reason why I say that is because say you accidentally do Control Z on something, you're like, oh my gosh, I needed that code. Control Y. Lifesaver. So yeah, no problem. And then just kind of like comment that out, and then yeah. Going on down. So now we want the total number of points. Total number of points, we do, for this Pokemon comparison, we add the HP, attack, and defense, special attack, and other numerical column headers. We'll add together into one total. For those that are kind of like that have some background in the Pokemon, I think you wouldn't do this because there are different types of metrics, and when you out of different types of metrics, literally that doesn't make sense from like a perspective of like scientific units. Sorry. So just like kind of have that, like, I know adding things together isn't that simple, though it is simple here. Just keep in mind, like, some of the analysis or kind of like the reflections that you come up with might be misleading.
Plus slash mark is just continuing.
Yeah, that's correct. So the plus slash sign is continuing into the next line. Here, with Jupyter Notebook, you don't have. Pretty sure you don't have to do the backslash. In Python, you do. Oh, wow, surprise. You need to do that. I'm pretty sure you don't need to do that in some cases. Maybe I'm wrong. But yeah. So here we have all those totals. Here, yeah, I'll just stop that. Kind of like ramble there. So now we're gonna sort these values for Pokemon comparison. And we're gonna sort by the total. And how we're gonna sort? How we're gonna sort those values? Either as, for ascending and descending. So ascending is where you want to start at the very top and then with the smallest number and then increase downward. Descending is you want to start with the largest values and then go down to the lowest values. For total, or no, for total. So we're sorting by total, and the largest number is 550, and we're just descending because our ascending parameter is false. And those dot sort values, some by condition, just like the group by condition, and some parameter. Get a shift tab for that. And then as a side note, in place equals false means, do I want to do this operation and overwrite the data frame simultaneously? I do not want to do that in place, so I set that to false. If I set it to truth, that's done. The operation's done. You don't have to do that. You save it as like the reference, the same column or whatever, and then like override it for the operation. And yeah, so then you would export it as 2 underscore something. You do 2 underscore reads 2 underscore CSV, 2 underscore Excel, and then just always when you export, make sure you have the correct suffix at the end. So .xlsx is an Excel file. For to a CSV, you want to make sure you have .csv. Find out if without it, if your file works or not. Let me know. That's it for tonight. Yeah, if you have any questions, TAs, me are here for the next 30 minutes. Yeah.
Show the addition.
Yeah. Yeah. This is good, right?
Yeah,
Size.
right. Yeah, go ahead.
Oh yeah. Is that good? Yeah, solutions.
Give us the